Start.
Hello everyone, I am 𝗙𝗲𝗃𝗃. Welcome back to our Smart Indians YouTube channel. In this video, we are going to solve Codeforces Type 3 contest problems. So let's get started. Okay, so let's start with question 1, which is ideal generator. So it is saying that we call an array A consisting of k positive integers palindromic. If you know the meaning of palindrome, right? So the original array should be equivalent to reverse of the original array. So for example, the array 1 to 1 and 5 1 1 5 are palindromic, and while 1 to 3 21 and 12 are not palindromic arrays. So we call a number k as an ideal generator if any integer n can be represented as sum of the elements of a palindromic array of length exactly k. Each element of the array must be greater than 0. Okay. For example, the number 1 is an ideal generator because any natural number n can be generated using the array n. So it is saying that k is 1 and just a single element in the array, you should be able to generate all the values of n which are greater than k. So here k is 1, so you should generate all the values which are greater than 1. So n here is sum of the array. So if you have a single element, to generate, we need to start generating from 1, right? To generate 1, I'll place 1. Next number is to generate 2, I'll place 2. Next 3, to generate 3, I'll place 3. So it is saying that number 1 is an ideal generator. You should be able to generate an array, a palindromic array, where for all values of n which are greater than k. Okay. So it is saying that, however, the number 2 is not an ideal generator. There is no palindromic array of length 2. Okay, that sums 3. Let's take for 2. Let's take for k equals to 2. If k is 2, you should generate all the sums which are greater than 2. If you have k as 2, that means you can place 2 elements starting from 2. Can we generate 2? Yes, by placing 1 and 1 we can generate a palindromic array where it sums to 2. Can we generate a palindromic array with 2 elements which sums to 3? Not possible, right? If I want to change this, if I put this as 2, this is not palindrome anymore. If I put this as 2, this is not palindrome anymore. If I put 2 and 1, even this is also not palindrome. So it is saying that for sum 3 it is not possible. So if you cannot do for a single value, it is not an ideal generator. It is not a ideal generator. Now it is asking us to determine whether the given k is ideal generator or not. You'll be given a k, you have to determine if k is ideal generator or not. Input format is, you are given test cases followed by, for each test case you'll be given a value k for which you have to say it is ideal generator or not. Output format, if it is for each number k, you need to output word yes if it is ideal generator, or otherwise no. Okay, let's look at sample input and output. So for input 1 and 2 we have already seen. For 1 it is yes, it is an ideal generator. For 2 it is not an ideal generator. Let's check for 3. If you have 3 elements, if k is 3, that means you need to generate an array of size 3. Then you need to start generating all sums from 3. Can you generate 3? Can you generate sum as 3? Yes. I'll put all the elements as 1. It creates an array which sums 3. To generate 4, I'll just change this to 2. So now sum is 4. For 5, I'll change this to 3. It is now becoming 5. What about 6? It is possible. I can generate 7. I can generate. If you see all the values of n which are greater than 3, I can generate a palindromic array with just 3 elements. So for 3 it is valid. Let's take something like 4. Let's say if you have 4 elements, let's say k is 4, that means your array going to have 4 elements. This has to be a palindromic array. So here you need to generate all values of n. N is sum of the array. So you need to generate all the values of n from 4. Can you generate sum of the array as 4 by making it as palindrome? Yes. First value you can put all ones. What about 5? What about 5? To make it 5, I have to increment one of the value. If I put this as 2, this is no more a palindrome. If I put this as 2, this is no more palindrome. Why it is not? Why were we not able to make the palindrome? Because if you have 4, that means these two elements should be exactly equal to these two. Let's generalize this. Let's say you have taken some value A, you have taken some value B here, and this has to be exactly same. So this has to be A. So let's say this sum is x. This sum should also be exactly equivalent to x, right? So when you add them up, you'll generate a number which is 2x. You'll get a sum which is 2 times of x. So 2 times of x will always be even. Any value multiplied by 2 will always be even. That means when you have k as even, you cannot generate odd sum. You cannot generate odd sum. It is not possible to generate odd sum. So if you observe the test cases carefully, for all the odd values, 1, 3, 73, output is yes, yes and yes. For even values, 2 and 1000, output is no. It is as simple as this. Check if k is even. If it is even, you cannot get a palindromic array for all the sums. For odd sums, you cannot get for even length array. For odd, we have just seen it is every single time it is possible to get a sum which is greater than k. So it is just that you need to write this simple condition. If it is even, it is no. If it is odd, it is yes. Let's get into coding. So first we have to scan the test cases. Let's create a scanner class. Let's create a scanner object by passing system.in. Then let's read the number of test cases. Next int, and while I'll iterate for each test case greater than 0, and for each test case I'll be given a value k. sc dot next int, and if I'll simply check if k is odd, that means I'll simply do k and 1. If it is 1, I'll simply print. If it is odd, it is yes. Else simply print no. As simple as this. If you see, for odd we are printing yes, for even we just have to print no. Let's see B, expensive number. The cost of, it is saying that the cost of a positive integer n is defined as the result of dividing n by sum of its digits. So cost is nothing but n by sum of digits of n. This is what cost is. So using this example, you can understand that if you have 104, 104 is divided by sum of its digits, 1 plus 0 plus 4, which is 5. 104 by 5, which results in 20.8. Okay, same thing for 111 divided by 3, 1 plus 1 plus 1, 111 divided by 3, which results in 37. This is how you compute the cost. You are given a positive integer n. That doesn't contain leading zeros. You can remove any number of digits from the n, so that remaining numbers remaining number contains at least one digit and it is strictly greater than 0. The remaining digits cannot be rearranged. Okay, it is saying that we cannot rearrange. As a result, you may end up with a number. Okay, so if you remove some digits, it is okay to have leading zeros. Okay, so we are given example with 1035554. It is saying that if you remove digits 1, 4, 5, if I remove 1, 4 and 5, we'll end up with 0, 3 and 5. We have leading 0, which is completely okay. Now to find the cost of this number, we have to simply divide with the sum of its digits, which is 8. If you divide 35 by 8, we'll get something like 4.3 something. Okay, it is given some exact value 4.375. Okay, so this is going to be the cost once you remove 1, 4 and 5. So we have to find minimum number of digits you need to remove from the number so that its cost is minimum as possible. So you have to remove some digits, such that its cost, okay, let me write it here. We have to remove digits. We have to remove some digits such that its cost is as minimum as possible. Right? Let's try to understand. Using sample independent output. So for 666, 6, 6 and 6, the output is 2. That means you have to remove two digits. It doesn't matter which 6's you remove. Let's say we go with removing first 2 6's, so it results in a value 6. Sum of it is 6, it is 1. What will happen if I remove just 1 6? It is 66 by 6, resultant would be 11. Okay, let's try for a different value, 137. So for best, to get minimum cost, it is better to go with removal of 2 6's, so which results in 1. Next test case is 137, 0 and 0. So it is saying that our output should be 4. So which digits to remove, which 4 digits to remove such that the output is minimum? And I should also make sure that the resultant number, the remaining number, the left out number should be strictly greater than 0. So that means I cannot remove these three digits and it is 0 0, sum is 0. I cannot do this. This is completely wrong because the resultant should always be greater than 0. Here it is not. So the best case would be I'll remove 1 3, I'll keep 7, I'll remove these two. I'll remove 1 3, I'll remove 0 and 0. It doesn't matter if you just keep 7, it doesn't matter if you just keep 3. Anyhow, the resultant going to be 1. Why? If you have 7, you'll end up dividing by 7, you'll get 1. If you have 3 instead, you'll end up having 3 as the remaining number, 3 by 3, which also results in 1. So ideally, at the end, once you remove some numbers, the remaining number should always be greater than 1. If we want to follow this constraint, that means it should be a non-zero digit. Yes. And if you observe one more thing, to get minimum cost, where it is 1, to get cost as 1, that means at the end we should be left out with just a single digit. To get cost as 1, we should be end up with a single digit. It doesn't matter which digit you end up, but the digit you are ending up, it should be a non-zero, because we have to follow this constraint. It is saying that at the end, once you remove some digits, the remaining number has to be greater than 0. Okay, let's look at one more example. 137. Okay, we have taken this. Let's go with 102030. For this, output is 3. That means I have to remove 3 digits. What is the best way to remove 3 digits such that it is greater than 0, such that remaining number is greater than 0? Don't assume that I can remove all these digits. It ends up with a value 3 zeros, but it is not following these constraints. I cannot do something like this. That means I have to have a non-zero digit. As I've said before, best way to remove is I'll remove 1, I'll remove 2, I'll remove this 0. That means I'll end up with 0, 0, 3. Sum of it is 3, and 1 is the minimum cost that I can always get. So what can you observe by these 3 test cases? In this, can I go with 2? Can I instead remove 3? Can I go with 2? If I do something like that, so it's going to be 0, 2, 0. Sum of its digit is 2. It is this 0 to 0 will represent a value 20. So 20 by 2 will end up having 10 as the cost. But minimum cost that we have to achieve is 1. So to achieve this one, what can you observe? It is not to have 2. It is better to have 3. That means I should have rightmost non-digit number, non-zero number, rightmost non-zero. And why I have to take with non-zero number? What was the difference between these two? What is the difference if I've taken 2? What is the difference if I take 3? Let's try to understand this more clearly by generalizing this. Let's say you have some numbers. You have some numbers like this. You have x here, which is non-zero. You have y here, which is non-zero. Let's put it here. I'll put zeros in between. Why it is always better to consider rightmost non-zero? Why not this one? The reason is, if you are trying to consider this, we want to have cost as 1. So if I am considering this, I should also remove these zeros. I can only have 1 0. I can only have 0 and y as the remaining number. But instead if I have x at the end, I'll generate a number which is 0, 0, x by removing this 0, by removing this x. So I can keep these zeros. If you see, it is not just reducing the cost. It is also that you have to remove minimum digits. So to remove minimum digits, it is always better to consider rightmost non-digit number. Okay. So let's code it up. So if you observe in the input, it is saying that n can range from 1 to 10 power 100. If it is 10 power 100, it's gonna have 100 zeros followed by 1 1. That means in total 101 digits. Can you store a number which has 101 digits in primitive data, in any of the primitive data type? Let's say integer. Can you store a number which has 101 digits in an integer? Not possible. Why? At max you can only store 10 power 9 as a value. In 10 power 9 you'll have 10 digits, 1 1 1 followed by 9 zeros. What about long? In long you can at max store 10 power 18. 10 power 18 is nothing but 18 zeros and 1 1, so 19 digits. Roughly we can store 19 digits, so even we cannot use long. So using which I can store a number which has 100 digits. If I cannot use these two, you can always go with string. You can store this number as a string and you can manipulate, you can perform operations on a string. whenever you are given a number which cannot be stored in int or long, you can always go with string. So I'll read each number as a string. N equals to read string sc.next. Then I'll simply iterate. I'll iterate on the string. I need rightmost non-zero digit. So to get rightmost non-zero digit, I'll have rightmost, let's say rightmost non-zero digit. Let's say this is minus for now. I'll iterate in reverse. I'll start from n minus 1. N is a string. I'll start from size minus 1 index and I'll come in reverse. I'll decrement it. Then if I see if it is non-zero, that means n dot caret I. If it is non-zero, that means if it is not equal to 0, I'll simply store it in rightmost non-zero digit. As I have to have that digit, I'll have that in my remaining digits. So once I have it from this non-zero digit, which is 3, before 3 I can have any number of zeros. So I'll consider all the zeros, right? So I'll count how many zeros are there before this 3, that which is rightmost non-zero element. So I'll again start from the beginning, from 0 to, I'll just go till rightmost non-zero digit and I'll increment it to maintain the count for zeros. I'll say zeros count, initialize with 0, and whenever I find a 0, n dot caret I. If it is 0, I'll simply increment zeros count. I have the number of zeros before this rightmost non-zero digit. So what will be the answer? How many digits you have to remove? At the end, I'll have these zeros which are before rightmost non-zero digit, and I'll have this non-zero digit. So at the end, I'll have int remaining count is zeros plus this one rightmost non-zero digit, and it is asking us to print minimum number of digits that we have to remove. So it is just, at the end I'll have this, the remaining or the digits I'm going to remove is the length of the string minus remaining count. Let's quickly run it. Okay, just a small typo, it has to be length. So we got output as 2430. Yes, expected is also 2430. Let's start with question 3, which is simple repetition. And it is saying that Pasha loves prime numbers. Once again, in his attempts to find a new way to generate prime numbers, he became interested in an algorithm and which he found on the internet. And the algorithm here is to obtain a number y, repeat k times the decimal representation of x. So we are also given a number where if x is 52 and if k is 3, to get y we have to put 52 3 times. This is how we obtain y. Pasha really wants the resulting number y to be prime, but he doesn't yet know how to check the primality of numbers generated by this algorithm. Help Pasha and tell him whether y is prime or not. We just have to figure out whether y is a prime number or not. And we already know what is prime. Prime, if a number is prime, that means it has only two divisors. One is 1, other one is itself. Let's say x. If we are checking x is prime or not, it will only have two divisors. One is 1, other divisor is x itself. Right, so we just have to tell whether y is prime or not. So let's see the input format. Input will be given test cases. For each test case we are given x, we are given k. Okay, so what is the output? We just have to output yes, we have to just output s if y is prime, otherwise no. Let's try to understand this with the sample input. Okay, so we have 52 and 3. 52, 52, x is 52. So first test case is 52 and 3. So x is 52 and k is 3. That means to get y, we have to keep 52 3 times, 52, 52, 52. Now you have to simply check if this is prime or not. You have to simply check if it is prime or not. How will you check if a number is prime or not? What is the logic to check if it is prime or not? If I give you x, what is the logic to check if it is prime or not? We have to find whether x has other divisors other than 1 and itself. If other than 1 and x, if any number is dividing x, that means if there is a number which is divisible of x, that means x is not a divisor. So to find another divisor other than 1 and x, we can simply loop from 2 to square root of x. Check if each of the value, let's say this is I, simply check whether I, which is ranging from 2 to root x, is divisible of x or not. This is logic. Let's put this aside. This is okay, but is there any problem with this approach? You are given x and k, you'll simply generate y and you'll simply pass y to this function. But is there any problem with this? Yes, there is a problem. The problem is you are given x as 1 to 10 power 9. Let's say x is 10 power 9 and k, let's take maximum, k as 7. That means you have to put x as k times, that means 7. 3, 4, 5, 7, 8, 9. This is one occurrence of x. Like this, you have to put 7 times. If you put 7 times, will it fit in long or will it fit in integer? 10 power 9 itself is a maximum value for int. We cannot go storing y in an integer. What about long? If 10 power 9 arranged 7 times, so 10 power 9 will have 10 digits into 7 times, this is gonna have 70 digits, right? Can 70 digits fit in long? No, not possible. So one option is go with string. If you go with string, it becomes difficult to check if it is prime or not, right? We cannot do something like this. It is not the best way to store as a string and check if it is prime or not. This is not the way. But is there any other way? Is there any other way other than this? Let's deep dive into first test case itself. We know that we can generate this and we can check if it is prime or not, but if a test case is something like this, we cannot really do that. So to check if it is prime or not, that means this 5, 52, 52, 52 should only have 2 divisors. One is 1, other divisor is itself 52, 52, 52. Is there any other divisor for this number? Yes, there will be other divisors for this number because we generated 52, 52, 52 using 52 by arranging it as 3 times. That means I can arrange 52 multiplied by 1, 52 multiplied by 100, 52 multiplied by 10 power 4, 10,000. Let me move this a bit down. That means this results in 52, this results in 5200, this results in 52 followed by 4 zeros. If I arrange this properly, it is nothing but addition of these will fetch you 52, 52, 52. If I came from here, that means obviously this number that we have generated is divisible by 52, right? It can be written as 52 into our summation of this, which is 10 power 4, 10 power 4 plus 100 plus 1. 52 into 100,101 will result in 52, 52, 52. There are other numbers using which you can divide 52, 52, 52. Okay, let's try to understand the same thing with a smaller example. Let's say x is something like 6 and k is, let's say, 3. That means you'll end up generating a number which is y, which is 3 6s. So we formed 6. Can I write something like this? 6 into 1, 6 into 10, 6 into 100, which results in 6. This results in 60. This results in 600, which in turn results 666 value. Is there any other numbers which are divisible by 666 other than 1 and 666? Yes, right, because I came from 6. Obviously 6 gonna be divisible 6 into 111. Other than these two numbers, there are also other numbers which are divisible, which divides 666. These are also divisors of 666, so it can never be prime. That means, can I say values for k which are greater than 1 will never be prime? Irrespective of what x is, if k is greater than 1, that number y can never be prime, because we are generating y using x by arranging it some number of times. That means I can always divide with x by some factor. So for k, if it is greater than 1, y can never be prime. Okay, so what if k is 1? We solved if k is greater than 1. What if k is 1? If k is 1, simply call is prime of x, because we know that x will always be less than 10 power 9. Call this function. Simple. But will there be just these two cases? Case 1 and case 2, will there be just two cases? Are we missing anything? If k is something like 2, what about x equals to 1? That means you'll create a number y which is 2 ones, which is 11. That means 11 is a prime, right? Any other edge cases like this? Any other cases which will violate this? Which will violate case 2? No, even for k equals to 3 and x equals to 1 will have 111 as y. So to check if 111 is prime or not, if it is prime, that means it should have only two divisors. One is 1, other divisor is 111. Is there any other divisor for 111? Can we divide with 2? No. Can we divide with 3? Can we divide 111 with 3? We can divide with 3, remaining is 2, this is 21, 21 is 7, so we'll get 37. So we can divide using 3. That means only it will be for this case, right? Any other value which is greater than 2 k is greater than 2, even it will k equals to 4, x equals to 1, even this is not prime. You can try checking that using the same way we have used for k equals 3 and x equals to 1. Right, that means we just have to handle for these three cases. This is first case, second case and third case. Just the conditional statements. If k is 1, just call is prime. If is prime is coming out to be true, print yes. If it is false, just print no. Just these going to be the conditional statements. That's it. Okay, so let's code it. So I have taken the scanner object. Then we have to read x followed by k. So I'll read x first, sc dot next int, and read k, sc dot next int. And once I read x and k, we have seen that if k is 1, we have to simply call is prime. So I'll simply write if k is 1, simply call is prime. If is prime of x, if it is returning true, simply print yes, else you can simply print no. This is one case if k is 1. You can also simplify these conditions. You can instead of writing these conditional statements inside, you can write it as something like this. You can directly print it. You can use ternary operator. You can call is prime of x, and if it is true, that means this is gonna execute. If it is not, this is gonna execute. You can convert this to a single liner. So I'll get rid of this. If this is not the case, instead of else, I'll write as else if. I'll handle this condition explicitly by mentioning k is 2 and x is 1. That means it is y is 11, so it is a prime number. I don't have to check it. If k is 2 and x is 1, this gonna generate y as 11, and which is prime. So if it is prime, I'll simply print yes. For all the other cases where k is greater than 2, greater than 1, I'll simply print no. This is it. Now we are only left out with implementing is prime, which you already know. I'll create private static boolean is prime as a function name, and I'll take x, and simply you can write some valid checks. If x is less than 2, you can directly return false. Otherwise, simply loop from 2. You can write math.square root, but instead I'll prefer writing like this: I into I, which should be less than or equal to x. I'll simply increment I, and if I is divisible, I is a divisor of x, then simply return false. That means other than 1 and x, there is a other divisor which is dividing x, which is divisor of x. That means it is not prime. I'll return false. Again, this is simple implementation of is prime that we discuss in our sessions. Okay, more or less this is it. Let's run it. Output is no, yes, no. Let's compare with no, yes, no. Yeah, so it is matching with the expected output. This is it. So that's it for this video. I hope you enjoyed watching this video. make sure you like and subscribe to our YouTube channel. And if you want to learn DSA in detail, you can join our 3-month Smart Coder course. And thanks for watching. We'll meet soon in the next video.